Our journey begins with the Cambrian explosion, a remarkable period approximately 541 million years ago. A time of extraordinary transformation. This era is often referred to as biology's Big Bang. Imagine, if you will, a world with simple, unicellular organisms leading quiet lives in Earth's oceans. Suddenly, within a geological blink of an eye, the biological landscape shifts dramatically. The Cambrian explosion marks the advent of complex multicellular life. The world stage, previously dominated by simple organisms, now witnesses an influx of a diverse array of life forms, from the first shelled creatures like trilobites to the ancestors of modern starfish and arthropods. The oceans teem with a burgeoning variety of life. What's intriguing about this period is not just the sudden appearance of these complex organisms, but also the diversity of their body plans. Evolutionary innovation seems to have been at its peak, with creatures exhibiting a myriad of shapes, sizes, and structures. This period gave rise to nearly all major animal groups known today, a testament to the creative power of nature. But what triggered this explosion of life? Scientists speculate a combination of factors. Perhaps an increase in oxygen levels or the development of predator-prey relationships that drove evolutionary changes. Maybe even a shift in the Earth's geography that created new and diverse habitats. The truth is, we may never know the exact causes. Yet, despite the mysteries, one fact remains clear. The Cambrian explosion was a pivotal moment in the history of evolution. It was a time when life on Earth diversified at an unprecedented rate, setting the stage for the complex ecosystems we see today. So, as we venture forth into other monumental eras of evolution, let's not forget the significance of this biological Big Bang. The Cambrian explosion sets the stage for the intricate web of life we see today. A time of unparalleled evolutionary innovation, it remains one of the most fascinating chapters in the story of life on Earth. Join me as we continue this journey, unraveling the tapestry of life, one thread at a time. Fast forward to around 2.4 billion years ago, where a monumental shift occurred with the rise of photosynthesis. During this period, our planet was undergoing a dramatic transformation. A new player had entered the scene, forever changing the course of life on Earth. This player was none other than cyanobacteria, microscopic organisms with a massive impact. Cyanobacteria were the pioneers of photosynthesis, a process that allowed them to harness the energy of the sun to transform water and carbon dioxide into glucose and oxygen. This was a game changer. For the first time, organisms were producing their own food using sunlight, a virtually limitless source of energy. But perhaps even more significant was the byproduct of this process, oxygen. Before the rise of photosynthesis, Earth's atmosphere was largely devoid of oxygen. But as cyanobacteria thrived and multiplied, they began pumping out oxygen in enormous quantities. This led to what scientists refer to as the oxygen revolution, or the Great Oxygenation Event. In a relatively short geological period, Earth's atmosphere went from nearly zero oxygen to levels similar to what we have today. But this change wasn't without its challenges. The release of oxygen was in fact toxic to many of the anaerobic organisms that had previously dominated the planet. It was a mass extinction event, but it was also an opportunity. With oxygen now plentiful, the stage was set for the development of aerobic organisms. These organisms could use oxygen to generate far more energy than their anaerobic counterparts, enabling them to grow larger and more complex. This laid the groundwork for the evolution of multicellular life and eventually the vast array of complex organisms that populate our planet today. The oxygen revolution was more than just a breath of fresh air. It was the spark that ignited the evolution of complex life, a turning point that set the course for everything that was to come. So, while cyanobacteria may seem insignificant, their impact is anything but. They paved the way for the biodiversity we see today, and for that, they deserve our recognition and respect. The oxygen revolution fundamentally altered Earth's atmosphere, creating the conditions necessary for the evolution of complex life forms. Enter the Mesozoic era, a pivotal time that witnessed the rise of dinosaurs and the evolution of various prehistoric giants. This era, often referred to as the Age of Reptiles, was a momentous chapter in Earth's history, spanning from about 252 to 66 million years ago. It was divided into three periods: the Triassic, Jurassic, and Cretaceous. The Triassic period marked the dawn of the Mesozoic era. It was a time of recovery and renewal following the devastating Permian-Triassic extinction event. In this era, the first dinosaurs, small and bipedal, began to appear, setting the stage for the colossal creatures that would dominate the Earth in the subsequent periods. The Jurassic period, the golden age of dinosaurs, followed. This period witnessed the evolution of some of the most iconic dinosaurs, such as the long-necked Diplodocus and the fearsome Allosaurus. The world was a lush, green expanse, teeming with life. Dinosaurs ruled the land while pterosaurs soared in the skies and marine reptiles like the plesiosaur thrived in the oceans. Then came the Cretaceous period, the final chapter of the Mesozoic era. Dinosaurs continued to evolve into diverse forms, from the armored Ankylosaurus to the bird-like Velociraptor. Plants too were diversifying, with the first flowering plants adorning the landscape. However, the end of this period was marked by a cataclysmic event that led to the extinction of the dinosaurs and the end of the Mesozoic era. But the Mesozoic era was not just about dinosaurs. It was a time of significant evolution and diversification across the board. The first mammals emerged during the Triassic period. Initially small and nocturnal, these creatures would go on to inherit the Earth following the extinction of the dinosaurs. The Mesozoic era, spanning 180 million years, showcased the dominance of dinosaurs and laid the groundwork for the evolution of mammals. It was a time of dramatic change and evolution, a chapter in Earth's history that continues to captivate us with its fascinating creatures and profound influence on life as we know it today. The Cretaceous-Paleogene extinction event, approximately 66 million years ago, marked a critical juncture in evolution. This was not simply an end, but rather a new beginning, a reset button for life on Earth. An event so catastrophic, it's said to have wiped out nearly 3/4 of all species, most notably the dinosaurs, those colossal creatures that had reigned supreme during the Mesozoic era. This extinction event is widely believed to have been triggered by a colossal asteroid impact, a space rock roughly 6 miles wide that slammed into what is now the Yucatan Peninsula in Mexico. The force of this impact was so immense that it caused wildfires, tsunamis, and a nuclear winter effect, where dust and debris filled the atmosphere, blocking out sunlight and causing a dramatic drop in global temperatures. Now imagine the Earth shrouded in darkness, a world in turmoil, species struggling to survive in this new harsh reality. But it is in this darkness that the seeds of a new era were sown. With the dinosaurs and many other dominant species out of the picture, new opportunities arose. The extinction event was indeed a reset button, a blank canvas. It opened up ecological niches that had been previously occupied, allowing new forms of life to emerge and thrive. This was the dawn of the age of mammals. In the aftermath of the extinction event, mammals, which had previously been small and nocturnal, began to diversify. They evolved into a myriad of forms, occupying the land, sea, and air. From the tiny shrew-like creatures of the Mesozoic, we see the rise of everything from the majestic blue whale to the agile cheetah, and even our own species, Homo sapiens. This catastrophic event opened up ecological niches, paving the way for mammals to thrive and eventually evolve into the diverse array of species we see today. The Cretaceous-Paleogene extinction event, as devastating as it was, laid the groundwork for the world of life as we know it. It's a stark reminder of nature's power to both destroy and create anew. Finally, we reach the evolutionary chapter that brings us to the present day, the rise of Homo sapiens. This is a tale of survival and adaptation, played out over millions of years under the ever-watchful gaze of natural selection. Our ancestors, the early hominins, first emerged in Africa around 7 million years ago. These bipedal beings, while far from our image of modern humans, set the stage for what was to come. Their ability to walk upright freed their hands, opening up new possibilities for tool use and interaction with the environment. As we fast forward through time, We see the emergence of the Homo genus around 2 million years ago, marking a significant milestone in human evolution. Species like Homo habilis brought a new level of sophistication to tool use, crafting tools that were more complex and diverse than those of their predecessors. The Homo erectus, who lived from about 2 million to less than 100,000 years ago, took innovation to new heights. They harnessed the power of fire, developed more complex social structures, and even began to explore outside Africa. Then, around 300,000 years ago, our own species, Homo sapiens, enters the scene. We were not the only human species around at this time, but we had certain advantages. Our brains were larger, allowing for more complex thought processes and problem-solving abilities. We developed language, enabling us to communicate and cooperate in ways that had been impossible before. Our ancestors began to create art and music, symbolic expressions of their thoughts and experiences. They learned to manipulate their environment, to farm and build, and to shape the world to their needs. And perhaps most importantly, they developed societies and cultures, complex systems of shared beliefs and behaviors that have evolved and diversified over time. This journey of adaptation and innovation has been a long and complex one, filled with challenges and opportunities, triumphs and setbacks. The development of intelligence, tool use, and social structures set humans on a unique trajectory, ultimately shaping the world as we know it today.